here's why we're all here to hear from Sandhya. Sandhya Vinjam, she is a technical lead and senior front-end engineer at DoorDash. She has 14 years experience in developing distributed systems at top technology company, including DoorDash, Meta, Amazon, and NVIDIA. She specialized in building highly reliable services and components, tackling diverse business challenges across these organizations. And Sandhya, she attributes much of her professional growth to excellent mentorship she has received along her career. And she says this played a significant role in shaping her journey. I'm with you in that mentorship is something amazing for her career. Thank you for talking to us today, Sandhya. We can't wait to hear from you. The floor is yours. Yeah.
Thank you, Anna, for a wonderful intro. Hi, folks. I'm Sandhya. I'm here to present high-scale security systems, especially in 0 to 1 product space. Let me share my screen. Okay, you all can see my screen, correct?
Yes.
Awesome. Hello, all. I'm Sandhya. I'm currently tech lead and also senior software engineer at DoorDash. And here I am presenting like what is security and what it takes to build like secure systems in big at scale products that you build, and especially when you are building some product that is from ground up, how do you make sure you give enough importance to security so that you gain your stakeholders' trust. Awesome. So a little bit introduction about myself. Like I think Anna gave me a wonderful introduction already. I'm Sandhya. I have 14 plus years of experience in building high scale distributed systems at different companies. I have experience in solving different business problems. In Amazon, I was solving like supply chain management related problems, and in Meta I was majorly solving how to build scalable and also secure infrastructure so that the whole Facebook is up and secure. So, and in DoorDash, I'm like it's a little bit different journey in DoorDash. So DoorDash, I moved to product teams where um, how to build like I was one of the founding engineer in a team that is responsible for convenience and grocery delivery, similar to like if you go and order something on like walmart.com, then like my service actually provides services where a real dasher can go shop and deliver. So I got like a good opportunity in leading and also leading the whole product and building like platform-based solutions in DoorDash. So throughout my career, I solved different and also diverse business problems with scalable, reliable, and also secure software components in place. Cool. So here is the quick agenda of today. Like I'll quickly give an introduction about like what exactly is security and what it is in terms of like um, security importance in distributed systems, and what are the common solutions that are adopted by companies in order to like build security systems or security product, and some key traits about what are the like some realistic ways in adopting security solutions in your product. It can be 0 to 1 or it can be at scale. It really depends on what you are building. So we will quickly go about what are the key tips that you can actually follow in building secure systems. And let's go. Cool. What exactly is security? Security, in at least in this modern world, is protecting data and both in transit and also at rest. So, especially when you are actually building distributed systems, um, like which can have both front end and back end, you need to make sure your users are like sending the information securely, and you are storing that information securely. So users can be different, depends on the product. So if you are a social networking app, your users are actual users. If you are a delivery app like DoorDash, then your users are, it can be direct actual users, or it can be businesses who are actually like selling their stuff on the platform. So it really depends on what exactly you are powering through your product. But end of the day, high level, security comes to like protecting user data or stakeholder data that is in transit and also in rest. So why do we do that? So that is to, in order to gain the trust from your stakeholders. So you cannot just like leak the data that you have to some third parties or some like attackers, which might have sensitive information. It could be personally identifiable information or financial information. So it can be like any sensitive information. So you have to be really careful when you are building products, so that you can actually gain your user and also stakeholder trust. So that is the importance, and why it is more important in distributed systems. So when you are building a product, or a service, so what you do is you try to leverage the existing distributed systems, because you might be serving audiences or your stakeholders across the globe. So for example, like Facebook app, though like it started in USA, like most of the users are like it is beyond United States in terms of usage wise. So in such cases, Facebook try to deploy their services across the globe in like different geographical locations. So and those components try to communicate over like the real internet, which is not secure in its own way. So it's really important to actually like make sure like you are like communicating securely across your services globally. So it's also other important things in distributed systems is you have to make sure like one user data is not visible to other information, like other user, because like if you send a if you own Facebook, and if you are using like if a user is actually uh, giving their payment details, then you need to make sure that payment details are not visible to other users of Facebook, and especially the attackers. So you need to make sure you provide a secure system, secure way of communicating that information over the internet from attackers and also from other users. So that is why it is really important in building secure systems and distributed systems. Awesome. So what are some common solutions and strategies that you can follow to achieve this security at scale products that are like used that are built using distributed systems? So there are like this is not a new problem. So these are the problems that are solved, and that's why like even government have actually poses some critical laws around, like every company has to obey some laws, so that they are responsible over their users and also stakeholders information. It can be like personally identified information or financial information. Sometimes it can be as simple as your location information, where exactly you are living. So if you think of strategies, then these are some strategies that that are kind of like best way to address, even when you are like to figure out like what are the problems in your what are the security problems in your already established company, or if you are establishing a new product, then like try to follow these strategies, then you will be in a better shape, and you will be at least like at a check mark of, okay, I am secure enough in building a product. So these are the pillars or strategies: data compliance, data isolation, and data security. Let's see what is exactly is compliance. So what exactly is compliance? So this is compliance are some rules and guidelines around managing and protecting data in a way that follows some laws and regulations. So there are some like why do we really need this? Correct. So there are some examples like CCPA, that is like California compliance law, and GDPR, like global data privacy laws, and HIPAA. HIPAA is majorly used for the pharmacy related, the pharma companies, the medical related compliance. The reason is protect the user data, um, from like like instead of like you own your users data and try to protect it and try to make sure you don't keep the data after a certain period, because you only need it for a certain amount of time for your business like up and running. I can give a simple example of HIPAA compliance. Like, so I like, for example, if I own a delivery platform, then like there are like, and for example, like Walgreens is my partner, and my driver is going and picking some items from Walgreens and delivering it. So I need to make sure I have enough, uh, only the information that is visible to driver is in such a way that it doesn't leak the finance information of the user. It doesn't leak the prescription information as well. It's not like if you go and pick up something from Walgreens, that is different. You can see like what exactly your prescription on the Walgreens. But when it comes to someone else is picking your medicines, they don't necessarily. It's not like they should not see your medical information. So that is one example of like with and without HIPAA compliance, how medical delivery occurs. So that is for a reason, because we don't want a unknown third person who is here to actually just deliver your package to know about your health condition, because they can deduce something from that information. And other than an information like first name and last name, the first name and last name is fine. And in order to deliver some information like location information is also used, but that should all be temporary. So whenever that order is completed, then we need to make sure that like the driver doesn't have information about the user anymore after that retention period. So that is really important. It's not only like during the delivery, it's also once your business use case is completed, no other leaks of information should occur. So how does this exactly happen? Like, companies do maintain retention periods for every business use case, and once that retention period is hit, then they go and redact all users information. Sometimes redaction is nothing but just like instead of putting my name as Sandhya and Vinjam, they are going to put customer, test last name, something like that, where nothing is like my identity is not revealed. And similarly, my location, they will just like go and encrypt with something that where like no one can understand. But sometimes my company or like the product that I work on might need that information for some future purpose. Even in that case as well, I should not store the information as straightforward as that user's information is identifiable. In those cases, there are ways to actually transform the data in such a way that you have the information about, for example, if I'm in a location where, like, for example, if my address is 123 maybe Broadway in New York, then if like the information that I might need as a company for future purposes would be analytics purpose. So I should not store the whole information. The information that is allowed to store is, okay, a user name test user belong to this zip code. A test user belong to this street. That's all. So it should not like directly identifiable to my personal identity. It should not be like directly related to my first name, last name, or email ID or phone number. So that's how like the things work. And data compliance is really important. So if you are not compliant, then there is a high chance that you'll be, as a company, you'll be paying lot and lot lot of money on fines. So especially for like compliances like GDPR, which is very strict in European countries, the fine can be up to 20 million USD. So the companies have to be really careful and responsible in using and keeping the users' data. Cool. So the next strategy that companies uses and also secure, like in order to build the security, is data isolation. So restrict access to entities. So this goes back to like one of the examples that I mentioned. If I'm like if I'm, for example, like facebook.com, and my user is actually giving me payment information, then I need to make sure I'm not leaking that information to other users, other parties, like other businesses or other group of people or other systems. So like let's call everything as entity. User is an entity, user is one kind of an entity, and business is one kind of an entity. And like there can be different entities when you are running a business, but you need to make sure like one entity information is not accidentally or by mistake is like shown to other entities. So that is the high level like goal of data isolation. This is really important because you have to protect your users' information in such a way that it's not leaked. Even within your platform, so it's not like, let's not like let alone like forget about the attackers within your system. You should make sure you have the boundaries by defining these entities with clarity. So isolation usually like established at different layer in order to implement isolation. So whenever you are ingesting your data, you actually go and interfere at that layer and make sure you are actually providing this entity information. You are creating the identities to identify these entities and making sure these identities are correctly attached to that data, so that during at the storage layer as well, these identities are associated even while retrieving the data. So at the retrieval layer, when you go and retrieve the data from the storage, that's the at that time as well, you go and use this identity information so that you are obeying these isolation strategies. So this is like what data isolation is, and how a company usually implements an isolation. The next strategy is data security. This is like pretty vast. So this majorly targets like building secure components in your, like when you are actually building your product. So it can be building secure services and also secure infrastructure. So and some things include, I'm just giving some examples, like securing your code. So that is one of the ways usually the malicious user comes and just grabs the whole product, is by putting some buggy code, some bug in the code, and then just he can get the whole access of your company or your product. So securing code is pretty important, and securing your communication. So it can be external communication from your stakeholders to your service, or internal communication when you are actually like building your components, and how everything like communicates securely. That is also important. And securing data at rest. So securing data at rest is nothing but like you store the information in a database or in a blob store. It really depends on your use case. Then how can a human can just go and cannot read that information and understand the sensitive information? So that is really important, because we need to make sure like even within the users that have the access cannot have the 100% visibility of the user's data. So some things are some techniques, secure techniques that are used are encryption. So when you go and store the information in data storage layer, try to make sure you encrypt that information so that it is not like very visible to the human eyes. And encryption works in different forms, symmetric and asymmetric keys. So encryption is usually like if I have the information 1, 2, 3, then I encrypt with a key. And so only if you have the key, then only you can actually decrypt that information. So the reason why the encryption is introduced is I have a service and I have a storage, and only my service should be able to read and update the information. Then what I do is I encrypt it with a key that I know. Then I go and protect the information in storage. I go and put the information in storage. Some other service can come and take a look at the data. They cannot decrypt because they don't have the key. And some other users can come and read the data. They cannot understand what it is. So only my service, who is allowed to read, have the key and can actually decrypt the information. So that's the beauty of encryption. So encryption happens at different layers. The example that I gave is just one layer in your infrastructure, and there are other layers like the external communication I talked about, which is traditionally used by HTTP protocol, like if you HTTPS protocol. So any company or any website is powered by, for example, like HTTPS dot wellsfargo.com. So the communication between, for example, if I have a Wells Fargo account, the communication between my page versus the Wells Fargo service, how it happens is over the secure communication, which is called like TLS, transport layer security. So that is used by asymmetric encryption mechanism, where the Wells Fargo has the like the private key, and asymmetric encryption comes up with the two different keys. One is public key and one is private key. Public key is can be visible to everyone. So as a user, I hold public key. So I mean, like in this case, though I am the user of Wells Fargo, I don't need to store because Google stores that information. Okay, Google, if I'm using Google Chrome. So and so Wells Fargo makes sure its public key is available to all browsers, and it is available at a common, like a public place where these browsers can actually go and get. And once that public key is available to browsers, then for example, if I click my username and password, that will be all like encrypted by the very first communication established is before even I provide the username and password. Whenever I click https.wellsfargo.com, then the very first thing is I will send a message like, okay, I want to connect with you to Wells Fargo with the public key encrypted. Then Wells Fargo sees that, okay, I am ready to listen to you. I'm ready to provide a secure communication. Then it actually sends another set of key that can be only like deduced by like this user. So overall, like after that exchange, then they will come to a symmetric. They both have the same key, and then like from that point onwards, they will actually communicate with the same key over a symmetric encryption mechanism. So they start with asymmetric because a Wells Fargo private key should not be visible to everyone. It should be owned by only Wells Fargo. So that is how things work. Because asymmetric communication is very expensive, they cannot like forever communicate with asymmetric communication. So only initial handshake will be done using asymmetric encryption, and after that it's all symmetric encryption. But the key will be known to only those two parties. So that's the like little bit brief about like how exactly like data communication, like data security works over the communication. Cool. So let's actually talk about what it takes for 0 to 1 product security. So we will see what are the ways, the real solutions. If, for example, if I have a product that has been already maybe recently established, or if I'm building something very new, brand new, how do I make sure, especially when it comes to as an engineer, how do I know like what I have to do? Like these, like so far, what we have seen are mostly concepts, and how do we make use of those concepts so that we can convert those to proper solutions and also proper designs so that we can address the security problems that we face in our product. Let's see. Security in 0 to 1 products. Let's talk about different strategies that we talked about with respect to more details here. So data compliance. So like what exactly, like how do you want to achieve the data compliance? So try to make sure you audit the sensitive information that you are storing. For example, if it is DoorDash, then it stores the information about the actual users. The sensitive information includes user's name, user's first name, last name, email ID, mobile, and address, which is also very like personally identifiable information, and finance information like my credit cards. And for DoorDash, there are other stakeholders like merchants. So merchants like Walmart, for example, if Walmart is on DoorDash, so we know like what exactly Walmart's um, uh, like store has, like what is the catalog information, what is the price information of every entity. So if that information is leaked, a competitor, for example, Walmart's competitor, maybe Amazon can quickly grab that information and then go and like get business advantage. So it's it's not just users, it's also other stakeholders when it comes to delivery app, that is business critical information, and also dashers, right? So dashers are also humans. So if you see the users, the end users are humans. Similarly, dashers are also humans. They have their personally identifiable information. So we need to make sure they are also protected, and their information is also stored only for temporary purposes. And if they are like permanent dashers, then like there are like defined guidelines around till when you can actually store their information. So so audit what is the sensitive information that you are storing. In DoorDash case, it is like you have different stakeholders and different types of information you are storing. And if it is like Facebook, you are actually storing users, not only just users personally personally identifiable information. You're also storing their likes, their, the places they visited. So like it's their like life events. So you have information about all these things. So you need to be like pretty responsible in securing that information. So audit the sensitive information and then understand what is the data flow, which services are actually storing that information. Service 1, service 2, service 3. Service 1's database is this, service 2 database is this. Service 3, for example, if it is using an S3 or some other blob storage, it is actually storing in that storage. And we have the traditional logging systems where we just go and log uh, personally identifiable information without even our notice as an eng. So you need to make sure, for example, systems like scalar logs, you need to make sure all those the data is redacted from those systems, because scalar logs are like visible throughout the company. So sometimes it is visible to the contractors that the company hires. So go and like put the enough measures around like redacting that information like immediately. Some redactions can occur immediately. For example, the logging system, you don't need to show the first name and last name in the logging system. So whenever you are logging itself, just make sure you enable your redaction flows, so that you only store the like you only store the publicly available information, or in like the not sensitive information in your logs. And other than logs, in storage you need to actually store the real information, because you are going to use it till you complete your business need. After the business need is completed, make sure you have proactive jobs. One way to do is establish asynchronous like workflows, or async like the chronos jobs, cron jobs. Establish cron jobs that actually go and do the proactive redaction than when company asks for, okay, did you redact my user's information? So you should not wait for that question. You need to make sure you already solved that problem before even your user or other stakeholder asks for that information. So that is how you proactively do. So establish some Cronus jobs and also guidelines around like what to redact. Is it like finance information or location information or personally identifiable information? So put the guidelines, and also retention periods as well have to be as strict as possible. For example, sensitive words like pharmacy, where you don't need to retain the data more than a week. And some worlds like grocery world, you can retain like businesses are okay if you retain the information for 30 days. So understand your stakeholders, like which the security zone they are falling into. Are they into like too sensitive zone in retrieving the information, or they are okay zone? So like like understand that and set some default retention periods, 1 week for pharmacy and 1 month for grocery. I'm just giving an example, so that you proactively launch your jobs after 7 days and then just redact all your like users information, so you don't fall into any security violations. And try to achieve 100% redaction when you run your job. If, for example, in real world distributed systems, you never have 100% SLA. Most of the times we have 99% SLA. That the code might fall into some or other error, but you always have to make sure 100% users information is redacted, because this is not something where we we treat 99% success rate is enough. It's always aim for 100% redaction. So if there are like some issues that persist, like some buggy code or something, then try to create security incidents and make it like sev zeros or sev ones, so that you address that. If the job is not doing it, you already have other ways of like manually go and delete the entry. So these are like one-off ways where you can actually, you still like aim for 100% redaction, but the channels might be different. Maybe like you can just go and run some database script. I'm just giving an example, but don't do it. Don't do it. Like database script where you can just redact the information, personal information of the user that did not succeed in the regular like the job. So that's how you make sure you are compliant. And the data isolation, this is very important and also very keen strategy that we talked. So isolate data so that one user's information is not visible to other user information. So how do you actually do it, right? So define the entities. In my case, like I just mentioned, like the entity in, for example, in a delivery app would be a user is an entity, and a driver is an entity, a merchant is an entity. So identify your entity and what are the different sensitive information that you are actually storing. So the audit that I explained in compliance strategy. So use that audit information and make sure who owns what data. Like like if you use DoorDash app to actually deliver to get your food delivered, you are the sole owner, and there are no, and DoorDash will make sure the information is not passed to merchant other than your first name and last name, or the like the basic information. But when you are actually dealing with B2B products, where you like the DoorDash doesn't own own the user information, but actually the Walmart does. For example, if you go and order something on Walmart.com, what Walmart does is it sends the information to DoorDash that, okay, can you deliver this package to this address with the customer name this, and this is the phone number. So in that case, DoorDash is the secondary owner. DoorDash is not the primary owner of the customer's data. So make sure like what is your role there, like who owns the data? Merchant owns the data. So you need to make sure you communicate with merchant saying that, okay, like what is the retention period, after how long we actually can like delete the data. That comes to compliance. When it comes to isolation, uh, you only have to show that Walmart's information to Walmart, but not to Dollar General. I'm just giving you an example there. So whenever a Walmart is giving this information of user via data ingestion layer, make sure the create your rule engine in such a way that every data ingestion have information about this identity. So like how do you like you make sure these rule engines work is then comes to this identity world, where you give identity to every entity. You give identity to customer, you give identity to, in this case, Walmart, you give identity to DoorDash. So you give different IDs of these, and you create your rules such that, okay, if this is the flow, if DoorDash is the secondary owner, then the rule is nothing but we are the secondary owners, and Walmart is the one that is actually is the primary ownership. So you need to attach that ownership mapping in your storage systems and also in your data retrieval systems. So that is the beauty of identity. So define your identity, attach your identity during data ingestion layer, and use that identity mappings during data storage layer. While retrieving the data, make sure only that identity have access to actually pull the information. For example, I am actually serving a dashboard which is like merchant facing. Then, like for example, like the Walmart and Dollar General. So I should not accidentally send Walmart's information to Dollar General. So that is the data isolation concept. So these are some key strategies on how you actually build. So define your rules, define your identities and entities, and define your identity mappings, and associate and use those identities at different layers. And the next part is the data security. This is like a little bit bigger space, building secure systems and secure components. So as I mentioned, you need to make sure the external communication is secured and internal communication is secured. So external communication, I already spoke about, like the TLS, the transport layer security. It's not transit, it's transport. So which is traditionally used by HTTPS. So like if you the Wells Fargo example that I gave, if you see the browser name as http.wellsfargo.com, you should not give any of your details, because that is highly likely that it's not a secured website. They are just mimicking the regular wellsfargo.com so that they can actually grab your Wells Fargo username and password details. So try to always check that lock key, which is HTTPS, where the server is actually providing a way of securely communicating your like the sensitive information. And that is external communication. If you come to internal communication, so once the data is into Wells Fargo systems, for example, and Wells Fargo, in order to run the banking system like Wells Fargo, we need, like, there are like 100 different services that are running at different geographical regions, talking to each other, communicating to each other. How do you make sure that communication is secure, right? So I'm in like Austin area, and and Austin area has some services running. And for example, Europe might be running some services. Like, how do you like communicate that? So there is something called edge security that comes into picture there. So whenever Wells Fargo servers that are running in this area actually like go over internet to this area, there is something called an edge. So there comes the edge security. So the edge security, what it does, it actually does the encryption, so that only that edge layer knows what is the key. So this edge layer knows, and that, like, the target edge layer knows, they both know the key. So that's how they actually communicate. So the whatever the data they are communicating over the internet is already encrypted. So that's how the edge security works, like within the infrastructure. Like, even like, forget about the external communication with user, within the infrastructure, how a service to service communication, or how zone to zone communication happens. So it is with edge security. So, and within, like, and there are like it's not only service to service that communicates, host to host as well communicates. So there is something called, the same kind of like identity comes into picture. So define your entities, like similar to data isolation. The concept is still same, but here the entities are, a service is an entity, a host is an entity, and sometimes a user can be entity. And it's like, okay, if a service that is payment service, for example, only like you should give only payment service act, like you should give like credit card informations, like reading and also using the credit card information to only payment service of your wellsfargo.com, but not to any other service. Like, other services could be like some notification service that is actually sending you emails, some, like, the basic transaction service where it just does like additions and like the just the like account information that holds the account information. So just account information, they should not have your credit card information. Only the payment service should have the credit card information. So even within like your infrastructure, some services should have information to some kind of information. Some services should have information to like access to some kind of information. There comes another set of like identities coming to picture. And how does the identities and everything is managed is via certificate authority. So every company have its own like certificate authority service, central service, that actually sits as a kind of a one person who actually gives identities to everyone. So it can be to a service, or it can be to a user, or it can be to a host. And what it does is, okay, you are service number one, and this is your key 123. Your service two, your key is 345. You are host one, your key is 679, and your type is host type. So what exactly it does is, when a service to service is actually trying to, if one service is trying to pull the information from other service, what that other service does is, okay, whether the sending service has the info, like has the access to this resource. So they can actually confirm that, okay, the resource, like end of the day, what exactly identities are defining. You have define identity and give access information, access control to the resources based like to these identities. So for example, user data information should only be given to user service. Payment information, like the credit card information to payment service, all those will be those rule engines will be maintained by something else called authorization service, so which actually maintains these mappings. And so every service, whenever it receives a request, it tries to go and checks with authorization service. Hey, like this, my like I received a request from this service. Does this service have resource access to this resource? Like, can the service get the payment information? If yes, then only I'll give that service payment information. Otherwise, I would not give. So that is how things work in practice. And most of the times, identities are defined by keys and tokens. And the next part of the next part of the security in building a product is code security, code package security, where a malicious user, okay, if I joined a team, if I join, for example, like Meta, and though I am a Meta employee, I might be a malicious user. The best way I could do is I could just go and put a buggy code and then like deploy it to all iOS servers or all iOS apps, where I can just grab all user information, all financial information. So that should not happen. So everything should be cryptographically signed. So this is another way of attesting. Like I spoke about certificate authority. That is one strategy for identities. This is something like signature infrastructure, you can call. Signature infrastructure in security world maintains that, okay, there is one person who actually, like, there is one service, that is cryptography service, that actually gives that actually signs the packages. So whenever a user, whoever is actually using it, for example, I am a service, and I need binaries to actually like to run my service. So whenever I received a binary, like I make a check that whether that's the signature on that binary is right. So I by talking to the cryptographic service. So you maintain that, send like interlocked system of like one authority. In previously it was certificate authority that gives identities. In this case, cryptographic authority, which actually signs the packages, which attests the signature. And then like on the end, on the other side, only the signature will be verified based on the cryptographic key. So and so that's how, like, only if I'm able to verify the signature, then only I go and actually, like, use that binary. I run a process using that binary. Otherwise, I will not do it. So that's how the code package security is protected. Because companies like Meta, they actually, like, they have the most threat because they own billions of users' information, sensitive information. So it's really important to, like, even if it is a very small service, that can actually create a cascading errors and cascading like infrastructure, like cascading failures that could bring the whole infrastructure down. So that is really important. So the next thing, the last thing is storage. Yeah, storage is encrypt your data in blob storage. I think I already talked about this. So if you are storing some information in your database, or if you are storing some information in your blob storage, like a Dropbox or S3 or something, try to encrypt it so that whoever have the access to that cannot read it. So in some cases, like for example, if I upload a file in S3 file which have some information which is publicly okay to, like publicly means if you go and take a look at S3, they also have these identities and access controls. So like even within a company, if I don't want someone else other than restricted users who wants to see this information, or like no user should see this information, only like this information should only be available in encrypted format, then go and use the symmetric key encryption and encrypt your data, and give that key to the authoritative service, so that that authoritative service can actually decrypt the whatever the data and then use it in a meaningful way and also secure way. So these are the like key things when you are actually building a product, or when you are actually doing an audit of your like already established service. So these are some strategies on how you can actually go and take a stab. So that ends my presentation. But any questions? Let's actually take last few minutes for any questions.
We have some questions in the chat.
Yeah. Okay. Cool.
I'm gonna read them out. I can read them out to you. So what are the consequences of a data leak to a company? And give some examples, and how can the company mitigate them, like in
Yeah.
an early stage?
Yeah, it's a very good question, because early stage products, they always try to go for like product market fit, and they are in the rush of, getting the product out. They don't even have time to actually give priority to security. So try to balance the world of like velocity and security is what I would call out here. So even if you build a perfect product that has like 10 features, and if you are not protecting your user information, then soon you will like have to face soon you will lose the trust from like your stakeholders. So try to get that balance, like leverage the third party companies. There are like a lot of third party companies that are in market, who gives these solutions like to you, like maybe like they can just establish everything within a week for your company. So try to use those solutions, and it might be little expensive to actually onboard to those, but it pays you well in long term. So you should not just look for the dollars that we are spending today. You should always, like, the trust comes with like, if you gain trust, then the dollars will follow. And similarly, if you lose trust, then if you are, for example, the fines are even more. So, and per user, for example, CCPA, per user they can charge up to 7,000. So if 100 data, if you leak users, like if you leak 100K users, then just imagine like how much fine you are going to pay. So try to leverage the third party solutions, and get away with, building the secure product. Let's go to the next question.
So yeah, what are the common security mistakes that startups make when building
Building mistakes
products?
startups make when building. So the common mistakes that they do are, they don't do the audits. So they might miss one of these strategies. So for example, most of the times data isolation is given least importance, to be honest, because most of the times they just care about, okay, if I don't put CCPA compliance, and then CCPA is going to put a penalty on me. So they mostly care about data compliance, but they don't really give importance about data isolation, which is equally important. For example, if I leak the data information of one business to another business, that itself is a very bad reputation. So I feel, especially like after working in DoorDash, and seeing like how 0 to 1 products build. The data isolation is the most ignorant case, but that is really important.
Good to know. That ties with my own question later, but that's a good, very good to know. I think for engineers who are looking to learn more as they
Yeah.
go as well.
Mhm.
So, what role does employee training play in preventing those security vulnerabilities in your project? Oh,
This is really important. So most of the times an employee can be an engineer or not non-engineer, and like to like the content might be different. Like the if you want to make your employee secure aware, you always come up with those like privacy and compliance and give the guidelines and also learning sessions. But I feel like there should be another set of learning session for engineers, when you are actually building your products, because it's like the details are like more important. So high level guidelines I have, but if I don't know how to put those solutions into practice, then how can I build secure systems? So I feel like there should be two ways, like two layers for this training: the traditional like employee training that targets both engineer and non-engineers, and one training should be specific to engineers, giving all these best practices and that are ad hoc solutions that companies actually putting in place to achieve this. So that how can an engineer can when they're actually creating a new feature, how can they make sure they are following all these security guidelines and they are not going back on the already established security product. I do see one more question here. At what stage should security become a priority in your product development? It really depends. So when you're actually just thinking about a product, it might be too early. But when you're actually in the design and implementation phase, uh, that's when you actually like make sure. The reason why it is important in design is the in order to make sure you have those isolations and identities and everything are clearly defined. Entities and identities are defined. So during design phase, once you make sure you have a product market fit and all those things, even if you have implemented something, and make sure it is extendable so that you put these identities and all as a another layer. So make sure you build systems or you implement systems so that the solutions are adaptable. Those are not rigid to adopt any security solutions.
thank you. Can
Mhm.
you share some examples of companies that, well, have gone through it, some error of this kind of, and successfully handled a security breach?
Um, Security breach. So Facebook have actually have had multiple security breaches, especially the code package security and all. So they did see major package hacks that happened, and some systems went down as well. I can't provide all the details because it's sensitive information, but you can actually go and read blogs and getting more help, like getting more information about that.
Yeah. And that ties into what you're saying about the teams, but can you recommend for developers and engineers who are, especially those who are starting and would like, they're not actually specializing in security,
Mm.
but they want to know more, and especially be aware of the regulations because you talked about them, and
Mm.
yeah, I think
Yeah.
every engineer should be
So
aware of
there
it.
are like a lot of resources that are available, especially like try to take the security courses. So, like, so security is one part, but that is not the only thing towards solving your business problem. So every business understand what exactly your company requires if you're already in a company. If you're still like an aspiring engineer and who wants to learn different systems, then try taking the security course. So there are like a lot of YouTube channels that are available. Try to take the security courses that actually teaches you about what is encryption, what is signing, what is public key infrastructure. So how the authentication and authorization works. So try to go to basics once you have the once you have strong fundamentals about basics and the concepts and way what is the use cases, then you can actually leverage those fundamentals towards in incorporating in achieving different strategies. It could be data compliance or data isolation or data security, but you really have to understand, like if you take data isolation, all these strategies, they have like some things in common. Encryption is common, signatures are common. So those are like security fundamentals. So try to go from there is what I suggest. Understand the fundamentals, and then what are the different strategies that company use. For example, in some companies like Meta, the data security component is the major thing, because most of the times they have to build this infrastructure secured. Where some 0 to 1 products where they can just leverage, for example, AWS infrastructure, where they don't have to up their services on their own. Like everything is kind of managed by some third party. You actually have to focus on data isolation, right? Like you have to focus on the business layer. How can you protect your business layer logic? Because, for example, if I'm using AWS infrastructure, and AWS itself is very secured and it is providing me all the infrastructural like security measures, so I can trust AWS. So then focus on data isolation and also data compliance. So yeah, I think that is helpful.
It is. Thank you very much, Sandhya. I think that
Mhm.
will be all of the questions in the chat.
Mhm.
And that was amazing. Thank you for the talk. And I think we have also, I was asking the question about resources. I think that's a great resource for people who are
Mhm.
interested in improving their security knowledges. And that was a great start for us and got us more interested without a doubt. So thank you very much for coming in today to sharing with us. And yeah, let's look forward to talking again soon.
Awesome. Thank you all, and for giving me this opportunity. So, I had great mentors throughout my career, and where I learned and grew as a software engineer, and built like the secure and reliable systems over the years. So, and I'm happy that I took part of this event so that I can give back to community. So there is like, this is not like the information I provided might be is not the like is very limited because we only have limited time. So you can always go, and if you're passionate, then just go and like try to see like what is the best way to learn quickly. So some tips are like try to understand like the chase towards like what exactly you are solving the problem. So understand like what do you want to solve, what problem you want to solve, and then like go from there. Like how do you address, and is the problem already solved or not? So and I know that most of the engineers who joined today are very passionate, and so I hope you go places.
Thank you.
Mhm.
And thank you for, yes, that's exactly the kind of community we are building here. And thank you for giving back. And that's very good to hear from you. That's the mentality we're fostering. I think it will help a lot.
Yep.
Um,
Thank you, Front and Queens team. Signing off.